know, if it were a different time of day, you might be more likely to see me at a different one of Asheville's venues, making idle chit-chat on the floor of a concert hall, waiting for that moment where the house lights turn out, the fog machine rolls in, the stage lights turn on, and the band takes the stage. We happen to be here first thing in the morning, so we don't have that, but I figured we got the crowd all together here, so let's have a show. And in fact, let's help stage an entire concert tour with the help of Ruby's coverage module. My name is Kevin Murphy, and I work at a company called PubMark. We help you find your next ebook or audiobook deal. Now, if you've heard of coverage, and it's fine if you haven't, it's probably been in the context of a conversation about test coverage, which is a metric to evaluate how much of your application code is run when your test suite runs, typically provided as a percentage. This is not a talk about test coverage. This is a talk about the tools you can use to measure things like test coverage with Ruby. Ruby's coverage module has 4 different modes. There's lines mode, one-shot lines mode, branches mode, methods mode as well. Threw that in there as a curveball. And we're going to talk about each of them today. So we have our set. Let's start the show. We're going to start helping out the band's guitarist, or more specifically, guitar tech. We're getting ready to get out on tour, and we need a lot of equipment, and one of the things we need a ton of are guitar strings. You see, when you play the guitar, you pluck the strings, and sometimes they just break. And if they don't break, then the tension loosens a little bit, and you play the note that you wanted to, and that's all great. But what makes a string break? Well, it breaks when the tension isn't set correctly, so we can predict that, that's great. But it also just happens sometimes. There's some randomness in the universe, and we can't predict this. And when a string breaks, it marks itself as broken, and it plays a sound that is not the one you wanted to play. So we're trying to figure out how many of these strings we need in case we need to restring an instrument during the show. And the truth is we just don't know. So we're going to guess for the first 10 shows of the tour and hope that we're right. We'll play the shows and we'll keep track of how many strings we're breaking and use that to place an order for the rest of the tour. And so you might think we can sneak in like a logging statement in the string class or something, just like something real quick, a one-liner just to keep track of how many strings we're breaking. But we're just about to get out on tour. The band has their instruments set up exactly the way they want. We cannot touch that instrument at all. The code is absolutely frozen, can't get anywhere near it. So instead, we're going to play the first 10 shows with the help of coverage. Coverage is part of Ruby's standard library, but if you want to use it, you need to require it. And you tell coverage to start running with the aptly named start method. Here we're going to start coverage in lines mode, which will tell you how many times each line of code was executed while coverage is running. We're going to use this to find out how many times we're breaking strings. So we'll load up the first 10 shows of the tour and find out what our coverage is by calling the result method on coverage. And what we get back is a big old hash. But let's talk about what's actually in this hash. Each of these elements are keyed by a string representing the name of a file executed while coverage is running, the value of which is another hash keyed on the mode of coverage. Here we asked for lines mode, so coverage very nicely gave us lines mode back. And the value of this hash in lines mode is an array of mostly numbers. And what these numbers tell us are how many times each line of code was executed. So order in this array is important. This first number is how many times line 1 was run. Lines 1 through 6 were each run 1 time. Line 7 is a special case. It doesn't mean it wasn't run. It would be 0 in that scenario. This is coverage telling us, don't worry about it. And if we go to line 7 in the source code, it's an empty line. So coverage avoids the philosophical discussion of what does it mean to have run or not to have run an empty line by instead just saying, I don't care and neither should you. It does this for comments, it does this for end lines, it does this for similar lines like that. So we're trying to figure out how many strings we've broken. So we need our lines coverage for our strings class. And we're going to say a string is broken when it sets that broken instance variable to true. And that's on line 54. So we're going to get into that array, and we're going to ask for array index 53, because arrays in Ruby are 0 indexed to represent line 54. And we see that we broke 16 strings over the first 10 shows, and now we have a definitely scientifically significant answer for a rock and roll tour for how many strings to order for the rest of the tour. So the guitarist can confidently go up on stage knowing that if they break a string, we have enough in the back to help them out. We got there thanks to lines coverage, which told us how many times each line of code was executed. That's not all coverage can tell us. Next, we'll help the band get ready for one very specific show. They've been booked to play a festival. And this is great news. They get introduced to an audience who otherwise might not come see them. They play a shorter than usual set, so less work, and the money's pretty good. It does have its share of challenges, though. They need to get on and off the stage really quickly. There's a lot of bands and a very strict schedule, so they need to make sure that they stay to that so they don't ruin the experience for everyone. And there's also only just so much room in the back with all of these artists and bands for all of the trucks and vans for all the equipment. So the crew's trying to figure out for this one show, is there some way we can reduce the amount of stuff we have on stage? And one of the things the band uses a lot of are synthesizers. Every member of the band plays the synth. Even if you're the bassist, you play the synth. If you're mostly a synth player, you're probably playing more than one. And when I said everyone plays the synth, I meant it. Here's a picture featuring the drummer. Notice they're not playing a drum kit, they are playing the synthesizer. They do use live drums, but in this instance, it was more important that they play the synth. So they have a ton of these instruments strewn about the stage, and the crew's thinking, if we can just get rid of one or two of these, it will save us a lot of time. And so we're trying to figure out if there's some way we can reduce the number of synths we have on stage. And the way that a synthesizer works is that it synthesizes different sounds. And these sounds are the result of spinning different knobs and turning different dials and moving different faders and pushing different buttons to generate different sound profiles. And on a digital synth, if you want to save these to recall them quickly, you can save them in something called a patch. And it's very important when you play the synthesizer that you set the right patch before you play the right note. Because even if you've played the right note, musically you've done the correct thing. But if you use the wrong patch, if someone's familiar with the song, it's going to sound weird, if not just straight up wrong. And now each of these instruments store their patches differently, but let's look at one of these instruments. This happens to be from a manufacturer right here in Asheville. They have their factory just down the street. They have a storefront. I was there yesterday. Go check it out if you have some time. And this happens to be an older instrument. It only has 4 bays of patch memory. So they use a case statement to access all of their patches. Right? So when a user hits one of the 4 buttons, it just accesses the different patches out of memory. And we're trying to figure out, for this one show, how many of these patches do we actually use? Remember, the band's playing a shortened set, so they're not playing some of the songs they regularly do. And so there might be some opportunity to consolidate. And now, luckily, with this being a different set, the band also needs to practice it. And so when they practice, we're going to set up the stage exactly as they would for a regular show, with all of their synths, with all of their patches that they regularly get. And the band's going to practice the show, but while they're doing that, we are going to once again use Ruby's coverage module. This time we're going to start coverage in one-shot lines mode. One-shot lines mode can't tell you how many times a line is run, but it will tell you if it is run. And that's all we need here. Whether a patch is used 1 time or 1,000,000 times during the concert, we still need it on stage, so this is sufficient to meet our needs. So the band's going to practice for the festival, and we'll see how many of these patches we're using. What comes back looks really similar to what we saw with lines coverage, but let's explain all of the elements again. We still get a hash keyed on the name of a file executed while coverage is running, the value of which is a hash keyed on the mode of coverage, and for one-shot lines mode, the value of that hash is an array of numbers. And what these numbers are different than lines mode. These are the actual line numbers that were executed. Because remember, one-shot lines doesn't tell you how many times. So if we want to find out which lines of our patch memory were used, we get back a bunch of integers. And we want to know which of these patches we used. So we're going to keep track of the line numbers inside the case statement to say this is how we prove that we accessed these different patches. Right? And we'll build some incredibly fancy output here to keep track of that and give us a nice little output here. And we see that for this instrument, we're using 3 of the 4 patches, which isn't great news in our consolidation effort. We definitely need this on stage. But if we perform this analysis for every other instrument, we might find one that we're only using one of its patches. And maybe we can find a similar enough sound on that first instrument that will allow us to not need to set up that second one at all, saving a lot of time and space, allowing the band to still play the show and have it sound the way that they want it to for the audience. A little more difficult for them because things aren't set up how they want, but allowing us to have the festival stay on track. And we got there with the help of one-shot lines mode, which kept track of if a line of code was covered to find out if we were using a patch. We're on to the second half of our show. We're going to talk about methods coverage. We're going to help out the lighting team. They have themselves a bit of a problem here. There's a spotlight on the lead singer, and sometimes during the show, it just goes out, and not when it's supposed to. And this is a problem because the lighting team takes a lot of pride in their work, but also the lead singer is a bit of a perfectionist. So let's just say they're well incentivized to figure out what this problem is. Now, similar to the band's stances on synthesizers, they also play with a lot of lights. Tons and tons of lights. Like, they work with lighting companies and special effects groups to design lights that didn't even exist before just for their tours. So they have a lot of small systems all working together, literally in concert, to produce this giant output. And we have one very specific small behavior that's not working exactly how they want in this giant monolith. Does that sound familiar to anybody? Right. So we have a very complex debugging problem on our hands. And the way that lighting works at a concert is that the lighting team are performers just like the band on stage, except they get none of the credit. But for every single note of every single show, of every single song throughout the entire tour, they're making sure that the right lights are turned off, the right lights are turned on, and the lights that are turned on are facing the right way, have the right color, are using the right effect, are moving the right way, so that the visual aesthetic of the stage looks exactly the way the band wants it, so the band can focus on playing the music. And now for our lighting system, we have a lot of different types of lights, but whether we're using a projector or a can light or a moving light or a problematic spotlight, all of them respond to this method called trigger. It's how you turn on or off a light. What those trigger methods do are radically different, but they all have the same named method. And one of the hypotheses for why our light is turning out is that there's not enough power at the venue, and it's taking it out on our spotlight here. And now you might think that's impossible. We have a contract, we have a tour rider with the venue that specifies exactly how much power we need, and they signed it. And you're correct, you've got me there. But I will say that sometimes honest mistakes happen. And it's just a hypothesis, we don't really know. And also as the tour's gone on, the band started playing different songs, which means they've stopped playing other songs. And there may be some lights that we only use for one song that we're not even playing anymore, but we can't keep track of it because there's just so much going on and so many lights. So the next time we play a show, we're going to set up the stage with all of the lights and all the rigging we regularly have, turn everything on, have the band play the show, and then tear everything back down again, moving it into the trucks and vans and heading off to the next city. But we're going to take advantage of this opportunity yet again to use Ruby's coverage module to figure out which lights we're using to see if we can turn some of them off and save some power. This time we're going to start coverage in methods mode to keep track of how many times methods are run, and we're going to keep track of how many times we're calling these trigger methods on these different classes. So the band's going to play the show, and we'll see what comes back. What we get looks different than what we've seen so far. So let's take an interest in what one of these elements are. We still get a hash, and that hash is still keyed on the name of a file executed while coverage is running, the value of which is a hash keyed on the mode of coverage. And for methods coverage, what you get for a value there is another hash keyed on a bunch of information identifying the method, and the value of that innermost hash being the count for the number of times this method in this file was executed while coverage is running. But I skipped over a bunch of stuff. We're going to talk about it now. Don't worry. We already talked about the count of this the value of this innermost hash. It's the count for the number of times this method was executed. And now for the keys going left to right, we have a constant representing the name of the class, a symbol for the name of the method, and then we get back 4 numbers. And these numbers tell us the starting line number, the starting column number, the ending line number, and the ending column number for where we can find this method in this file in the source code if we need to. Now here we're just looking to see if there are any lights that we're not using, and it turns out we set up a projector for every one of our shows, and we don't actually use it anymore. So the next time we go to light the lights, we can say, hey, not so fast there, projector. Thank you for your service, but we don't need you anymore. And hopefully that allows the rigging to have enough power to light the lights that the band actually needs for their show. And even if not, we've made the system a little less complex by taking the projector out of the equation. And we're able to figure out that we can remove it with the help of methods coverage, which told us how many times we were executing each method while coverage was running. We have one last song together here today. For our last song, we're going to get ready for the last show of the tour. We happen to be in a town that has another band in it that they're friendly with, and they've invited the lead singer up on stage and said, hey, come play a song with us. Let us know what you want to play, and we'll do it. So they figure out what song they're going to play, and it's one of the band's songs, but it's not a song they've been playing on this tour. So in the shows leading up to it, they've been using sound check to practice, so they're not playing it for the first time in front of a live audience. And so for sound check, the band knows what song they're going to play, and it's like mid to late afternoon, and the band ambles onto the stage, which might as well be first thing in the morning for a rock tour. Like all of us are gathered here today, we all made it in the morning. But there's some light stretching and talking about what they've been up to, and finally they get to playing the song. And it sounds all right, but something's a little bit off, and the band can't quite figure it out. And they're a relatively tech-savvy group, so they come to us in the crew and they say, hey, we know you've used this coverage thing to help us out a couple of times. Can you figure out what's going on with this song? And we're the crew, it's our job to say yes, so we say yes. But now we have a bit of a problem on our hands. Previously, we've been using coverage to answer a very specific question. Right now the question is, this sounds kind of weird? Which isn't even a question. But we told them we would give it a try, and so we don't really know if coverage can even help us out here. So we're going to start coverage in a special way. We're going to pass it the all symbol. And that tells coverage, run everything, tell me everything you got, I'll figure it out later. Right. So the band's going to practice the show at soundcheck again, and we'll see what comes back. And unsurprisingly, what we get is a ton of information. But what I want you to take from this is hopefully some appreciation for the data structure. Previously, we've been talking about how coverage gives you back the mode of coverage, and that's sounded repetitive, right? Because of course, we started in lines mode, we got lines mode back. You don't have to run coverage in one mode, you can run in a lot of them, and this gives a consistent way to access all of this data, whether you're running one mode or all of them at the same time. So we asked coverage to start in every mode, and what we got back was lines mode, methods mode, and branches mode. But we spent an entire section helping out getting ready for a festival with one-shot lines. So what happened here? Turns out there's an implementation detail in the actual C code for how coverage is written. So lines mode and one-shot lines mode can't be run at the same time. It will raise an exception. And now rather than coverage just raising an exception every time you ask it to run all of the modes, it instead chooses to use lines mode over one-shot lines. The reason for that is because lines mode can tell you the same information as one-shot lines. Lines mode will tell you if a line of code was covered. It will also tell you how many times. So when faced with the choice, coverage runs lines mode over one-shot lines. Enough procrastinating, time to actually figure out if coverage can help us out, figure out what's weird with the song. So we ask it if we're using every line of code in the song, and it turns out we are. So no help there. And if we're using every line of code, we're probably calling every method, but we had the data, so we had to check. And we ask for the branches mode, and we see a 0 here, which maybe piques our intuition, but we haven't actually talked about branches mode yet. So once more, for nostalgia purposes, let's all work together to talk about what comes back when you ask coverage for its result. You get back a hash keyed on the name of a file executed while coverage is running, the value of which is another hash keyed on the mode of coverage. For branches mode, the value of which is another hash keyed on each conditional in the file. The values of that hash are another hash keyed on each of the branches in the conditional in the file that were executed while coverage is running. So let's look at one of these branches and describe all of the data in here. You may have guessed already that the value on the right-hand side is the count for the number of times this branch in this conditional was run while coverage is running. And now going left to right through the keys, this first symbol identifies the type of branch. This is the first part of an if-else statement denoted with the then keyword, even though we don't typically use the then keyword when writing an if statement. This first number is an identifier. All branches and conditionals get an auto-incrementing unique identifier in branches mode. I don't know why, but they do. It's neat. And then these next four numbers are the same numbers from methods coverage, with the starting line number, the starting column number, the ending line number, and the ending column number to where to find this branch in the source code. And we're going to use that here, because you might see that this branch starts and ends on the same line. In fact, the entire conditional starts and ends on the same line. It's a ternary statement. So even if you were willing to make the leap of following where the then part of that is, you'd probably be even more confused when you just see this question mark colon syntax. So we're going to use the columns to say, hey, this 10 never gets returned. And that can be totally fine. Now we actually have to figure out if that's a problem. So let's take a step back and talk about what this code is doing. This sets up a vocal effect on the lead singer's microphone for all of the choruses that are supposed to wax and wane in intensity as the different choruses go on. But it's never waxing, it's only waning. And the reason for that is because when we start our song, we pass certain numbers into the chorus, and the numbers that we pass in don't meet both conditions of the conditional, so it always goes to the else case. And that's not what we want here, so we found an actual bug in our code. We can change that. It's kind of an off by one error. We pass different numbers in, and we have the band rehearse the song one more time at sound check, and we execute both sides of the branches. And after making that code change, our song sounds the way that it's supposed to, and they can confidently go up on stage with their friend for the last show of the tour, all thanks to branches coverage, which told us how many times each branch of code was executed while coverage is running. Branches mode gave us different information than we saw from the other modes, right? Lines mode told us every line is covered, and that was true. But we had one line of code that had multiple code paths inside of it, and one of those code paths weren't being executed when they should have. So what have we learned about coverage here today? Coverage has 4 different modes that can answer different questions for you. If you want to know how many times each line of code was covered, you can use the default mode, which is lines mode. If you don't care about how many times it was run, but just if it was run, you can start one-shot lines mode. The benefit here is that one-shot lines is a bit more performant than lines mode, because it doesn't need to keep track of a count of how many times, it just needs to know that it was run. If you don't want to mess with line numbers at all, but you want to know if a particular method was executed or how many times, you can use methods mode. And lastly, we just talked about branches coverage to tell us how many times each branch of code is executed. So now, with all of this newfound information about coverage, I'm willing to bet that it's unlikely, though conceivable, that you'll use coverage directly. But that doesn't mean that all this information is lost. You can use this to tune the tools available to you that do use Ruby's coverage module. I started by saying this wasn't a talk about test coverage, and hopefully that's borne out to be true. But there are tools that use coverage that can evaluate your test coverage, like the SimpleCov gem. By default, SimpleCov runs in lines mode, but you can tweak it and ask it to run in branches mode to get your test coverage of your branches mode, which might tell you different information than lines coverage does. There's also a gem called CoverBand, which runs in production. And if you want to use CoverBand to identify dead code, that is code that hasn't been used and therefore can safely be removed, then you don't care about how many times it was run, but just that it was run. So you can start CoverBand in one-shot lines mode. And now remember, one-shot lines is more performant. CoverBand runs in production, so anything you can do to minimize the overhead in all of your requests is of benefit to your users and also to you and your systems. So now you can take this information and apply it to your tools that use coverage to better meet your needs. If you'd like a copy of these slides, if you'd like a narrative description of coverage, if you'd like to know how to get and or stay in touch with me, you can get all of that information at kevinjmurphy.com/coverage. If you're interested in trying out Chirp and getting your first audiobook for 20% off, you can use code BlueRidgeRuby. I'll be honest, I don't know how long that code is valid for, That's not meant in like an act now way, it's just I legitimately don't know. I'm happy to take any questions or talk to anybody. I'll be just off the side of the stage over here and we'll chat individually. I want to thank all the organizers for bringing us all together here today, the volunteers for making this all happen. I want to thank all of you for being here. I hope you're as excited as I am to sit in those seats and listen to the rest of the talks coming afterwards. We have a great lineup here, so I hope you are super jazzed to be sitting where you are because I'm super excited to be joining you for the next 2 days. But nonetheless, I hope so far you've enjoyed the show. Thank you.